If we look at this, this is an example of a three-equation system with three variables from the last video, from part 1. And what we'll need to realize is that this system can be written as a matrix where we've got our x and our y's and then our separated solutions at the end. So we'll look at this real quick and then we'll show where this is coming from. Okay, so all we did is take anything that's in my x columns and I just took the coefficient. So I have a 1, a 2, and a 3. So you can see I have 1, 2, and 3 in my x column. In my y column, I have a 2, a -1, and a 0. So I have a 2, -1, and 0. If the variable does not show, that just means it has a coefficient of 0. Then in my z column, I have a 3, +1, -1, 3, +1, -1, and then my solutions are 9, 8, and 3, which I have that same exact thing written down here. Just a little neater so you can actually read it. So if I look at this, what I'm trying to do is I'm trying to go row by row, step by step, until I get 1s across my diagonal and 0s to the left of them. Okay. What we'll see here in our first one, and we should be able to notice, is that we do, in fact, have a 1 in our first spot here. So we don't have to do anything. We don't have to manipulate it. We already have a 1 that we're looking for. Now what we'll have to manipulate, though, will be this 2. Because I want that 2 to be a 1, remember. And if I look over here, what I'm doing in this row operation is I'm taking whatever was in row 2 and I'm subtracting 2 times row 1. So I'm going to take this 2 and I'm going to subtract 2 times whatever's in row 1. So for the first column I'll have 2 minus 2 times whatever's in row 1, which is a 1. And you'll see that's going to give me my 0. For the next one I'll have a -1 minus 2 times whatever's in row 1, which is a 2. I'll have a -1 minus 4. It's going to give me a -5. And then I have a 1 minus 2 times 3, which is going to give me 1 minus 6, which again will give me a -1 or a -5. So here I have my 0, my -5, and my -5 is my newly manipulated row. Now I have to do the same thing here with this 8. So I would do 8 minus 2 times row 1, 8 minus 2 times 9, which would be 8 minus 18, gives me a -10. So you can see this is where this manipulated row comes from. This 0, -5, -5, -10 comes from. It's just by doing that elementary row operation for that one row. So what I want you to realize is I got that 1 at 0 there. Now we did the same exact thing for this 3. I had to do some row operations to turn that into a 0. So I took whatever was in my row 3 and I subtracted it by 3 times row 1, and that's the beauty of finding a 1. Once you get a 1 in your main spot there, you can just subtract whatever your coefficient is, subtract that times row 1, and it will help you cancel it out. So I would have 3 minus 3 times row 1 gives me a 0 in my first column here. Then I have 0 minus 3 times 2. It's going to give me a -6. And then I would have a -1 minus 3 times 3 gives me a -1 minus 9, gives me a -10. So I have 0, 6, 0, negative 6, negative 10, and remember I gotta do the same thing for the last one. So 3 minus 3 times 9. So 3 minus 27 would give me a negative 24. So you can see this is where my entire row comes from here. It is a manipulated row. I took row 3 and subtracted 3 times row 1 from it. Okay, so like I said, the whole point of that is in that first column that we get a 1, 0, 0, which we have. Now, what we want to do is we want to turn this negative 5 into a 1. Anytime we have a negative 5, it's the same as negative 5 over 1. How do I make that a 1? Well, I'm just going to multiply by the reciprocal. If I multiply negative 5 by negative 1/5, I will get 5 over 5, which gives me my 1. So, essentially, I'm going to take row 2 and multiply it by negative 1/5. 0 doesn't change. It stays as 0. Negative 5 becomes 1. Negative 5 becomes 1. Negative 10 then becomes a 2. So I have my newly manipulated row. And we can see here, I'm starting to get what I'm looking for, which would be my 1s going here. I've got some 0s going here. So essentially all I've got to change now would be my negative 6 and my negative 10. To get rid of that negative 6, I can take negative 6, which I have here, and I can add 6 times row 2, because negative 6, let me do some erasing, negative 6 plus 6 times row 2 is going to give me a 0 in that middle row. Negative 10 plus 6 times row 2 is going to give me a negative 4. And my negative 24 plus 6 times 2 is going to give me a negative 12. So my new row is going to be 0, 0, negative 4, and negative 12. So you can see, like I said, we're getting closer. I've got my 1s and my 0s. Last thing I've got to get rid of now would be this negative 4. And to get rid of a negative 4, I can just multiply by negative 1/4. Really, the only thing I'm going to have to do is negative 4 times negative 1/4, which will give me a 1. Negative 12 times negative 1/4 gives me a 3. So you can see here down at the bottom, I've got my row echelon form. I've got my 1s going across, nothing but 0s to the left, don't care about anything to the right for now. So that would be my reduced row echelon form. And as I move forward one page, this is where we left off. This is my reduced row echelon form. I've got my diagonals, I've got my 0s. Now I can start to solve. Now remember, this was my x column, my y column, and my z column. So essentially down here, what this says is that z equals 3. What this middle row says is that 1y plus 1z equals 2. And what that top row says is that 1x plus 2y plus 3z equals 9. Now I could just go backwards. So I know that z equals 3. So I could say that y plus z equals 2. I know z equals 3. So y plus 3 has got to equal 2. I can solve there and I get y equals negative 1. So now I know z equals 3, y equals negative 1. I can plug those in for this equation. So I've got x plus 2y plus 3z equals 9. Don't know x yet. I know that y is a negative 1. I know that z is a 3. And I've got my 9. So I've got x minus 2 plus 9 equals 9. X plus 7 equals 9. X equals 2. So I could say my solution to this system would be x equals 2, y equals negative 1, z equals 3, which can be written as x, y, z. And that's how I solve a system of 3 equations with 3 variables.